Black holes have long been described as eternal prisons. Nothing can escape their grasp, not matter, not light, not even the flow of time itself. They are the ultimate cosmic titans, seemingly immortal, unchanging, and omnipotent. Yet, paradoxically, they are not eternal. In the 1970s, physicist Stephen Hawking revealed a shocking truth. Black holes emit a faint form of radiation, now known as Hawking radiation, which gradually bleeds away their mass. Even the mightiest black holes, those supermassive giants anchoring galaxies, will eventually evaporate completely. If the final survivors of the cosmos are doomed to vanish, what becomes of the universe itself? What is left when the last cosmic titan fades into nothingness? Tonight, we journey not to the birth of the universe, but to its final fate. We will witness the slow, silent death of everything, culminating in the disappearance of the very last black hole. This is a story of impermanence, awe, and cosmic mystery. The universe as we observe it today is alive with light and energy. Stars blaze across countless galaxies. Each star is a nuclear furnace, burning hydrogen into helium, creating the energy that lights the cosmos. Our own Milky Way galaxy contains roughly 400 billion stars, forming a vast spiraling disk 100,000 light-years across. Surrounding them are planets, asteroids, and clouds of gas and dust, the raw materials for future generations of stars. Stars come in different sizes and lifespans. Massive stars burn hot and fast, sometimes for only a few million years. They explode as supernovae, leaving behind neutron stars or black holes. Smaller stars like red dwarfs burn dimly and slowly, potentially lasting for trillions of years. Black holes are scattered throughout the universe, remnants of massive stars' deaths or products of galactic formation. Stellar mass black holes weigh only a few times the Sun's mass, while supermassive black holes, millions or billions of times heavier, reside in galaxy cores. Our Milky Way hosts Sagittarius as star, a black hole with 4 million solar masses. For now, stars and black holes coexist. Galaxies spin, stars shine, and planets orbit. But this balance is temporary. Stars eventually die, and when the last star fades, black holes will rule the universe alone. Stars are the lifeblood of the cosmos. They create light, heat, and elements necessary for planets and life. Yet all stars have finite lifespans. The Sun, our own star, will exhaust its hydrogen fuel in about 5 billion years, swelling into a red giant before shedding its outer layers and leaving behind a faint white dwarf. Massive stars live fast and die violently, exploding as supernovae that can outshine entire galaxies for a brief moment. Even small red dwarfs, which live for trillions of years, are not eternal. Eventually, the universe will run out of the raw material needed to form new stars. Star formation will cease, leaving galaxies dark and empty. Trillions of years from now, all stars will have burned out. White dwarfs will cool into black dwarfs, neutron stars will lose their heat, and red dwarfs will fade. Galaxies will no longer shine, space will grow cold and silent. In this darkness, black holes will remain as the universe's final rulers. They are the ultimate survivors, the last remnants of matter and energy. With stars gone, the universe enters the black hole era. Black holes, both stellar mass and supermassive, dominate. They drift through empty space, occasionally merging, growing larger and consuming remaining matter. In this era, the universe is quiet but not lifeless. Black holes slowly interact, forming binaries or clusters, consuming whatever drifts too close. Galaxies as we know them dissolve. Stars, planets, and gas clouds are gone. The cosmos is largely empty space punctuated by the dense points of gravity that are black holes. But even these cosmic titans are not immortal. Hawking radiation gradually diminishes their mass. The universe, over unimaginable eons, grows colder and darker. Energy becomes diffuse, motion slows. The final cosmic structures begin their slow decline. This is the era where entropy dominates. The universe drifts toward maximum entropy, a state where no organized structures can form, and motion becomes minimal. Black holes are the last reservoirs of order in an otherwise decaying cosmos. Hawking radiation is subtle but powerful over long time scales. Black holes emit tiny amounts of energy, gradually shrinking. For stellar mass black holes, this process is practically imperceptible over the current age of the universe. For supermassive black holes, the evaporation process takes trillions upon trillions of years. As a black hole loses mass, its temperature rises, accelerating the radiation. Eventually, it reaches a tipping point, culminating in a dramatic, brief, final burst of energy as the black hole disappears entirely. When the last black hole evaporates, the universe reaches absolute heat death. Matter is gone. Energy is evenly dispersed. No structures, no light, no events remain. Time, in a practical sense, has no meaning. The cosmos becomes a silent void stretching infinitely in all directions. Picture the universe with only one black hole remaining. Stars are dead. Galaxies dissolved. Planets drift endlessly in darkness. This black hole slowly radiates hawking energy, shrinking over eons. Finally, it evaporates. The universe becomes entirely dark, silent, and empty. There are no observers, no events, no motion. This is the final state, maximum entropy, heat death, and cosmic silence. Existence as we understand it ceases to function meaningfully. Time may still exist mathematically, but nothing changes. Space exists, but it is devoid of events. The universe's story, from the Big Bang to the final black hole, reaches its quiet conclusion. Even in its silent, empty state, the universe's story is profound. From the Big Bang to the last black hole, cosmic laws, gravity, electromagnetism, quantum mechanics governed every event. Stars, galaxies, and life emerged from simple matter and energy, shaped by these immutable forces. Civilizations like ours arose to observe and question the cosmos. Though the universe ends in emptiness, its legacy survives in its laws, in the structures it once formed, and in the understanding gained by sentient beings. The universe's silent finale is a reminder of impermanence. It highlights the fragility of life, light, and time. Yet it also showcases the beauty of existence, the power of physics, and the extraordinary journey from chaos to complexity. The universe's story, from fiery beginnings to silent endings, is extraordinary. Even when the last black hole disappears and time loses practical meaning, the journey of the cosmos remains remarkable. This narrative teaches impermanence, awe, and curiosity. It reminds us that all things are temporary, and that meaning can be found not just in the universe's existence, but in the journey itself. As we contemplate the last black hole and the universe's final fate, we gain perspective on our place in the cosmos. We live in a fleeting moment of light, a temporary oasis of order in an ultimately entropic universe. The last black hole will vanish, and the universe will become a silent void. Yet through our understanding, observation, and imagination, the story of the cosmos endures. Its legacy in knowledge and wonder is eternal.